Okay, today's short set of notes, we're going to review a little bit about molarity and then give you another worksheet so you have more chance to try and show that you can actually master this concept. Now, molarity is moles of solute per liter of water, solvent added. Is that true or false? Molarity is moles of solute per liter of water, well, solvent added. True or false? Well, the answer is false because molarity is moles of solute per liter of solution. Remember, if you have some solute and you add water to it, the volume isn't going to be the same as the volume that you added. The solute takes up some space, so the volume will actually be incorrect. So in this example, if you had a mole of solute and you added a liter of water, it won't be a liter of solution. It'll be more than a liter of solution, and the molarity will not be 1 mole per liter. It'll be 1 mole per like 1.01 liters or something, and it's not the same thing. Okay, so what is molarity? It's just another way of describing solution composition, and this time we're using moles in volume in liters. So molarity is the number of moles of solute per volume of solution in liters, okay? We abbreviate it with a capital letter M. You can see here it's all shown molarity equals mole solute per liters of solution. And that's one way of writing it. I actually like to abbreviate it N over L, where N is moles. This is the standard abbreviation for moles. And L is volume of solution in liters. So this is a very, very common formula in solutions. And it's important to understand how to use it. So here's a very simple problem. Okay, that's coming up. So solving molarity problems sometimes requires rearranging this formula a little bit. So here's an example. How many liters of a 0.25 molar solution could be made with 2.345 moles of sodium chloride? All right, well, let's see, what do we have? We have molarity and we have moles, but we're solving for liters. So once we can substitute in our values, you can see we got to solve for L. So in order to solve for L, we multiply both sides by L and then divide both sides by 0.250. So if you look at it, to get L by itself, it's going to be 2.345 divided by 0.250 molar. And that's going to give us a 9.38 liters of solution. That's how much we could make with that many moles and at that concentration. We can make a lot of solution. Now, molar mass is very important to understand because most of the time you're not told the moles. A lot of times you're told the number of grams, or we have to calculate how many grams of a solute to add to make a certain solution. So most of the times we get grams and we get the formula of the solute. Now, if we need to find moles, we have to find moles in order to solve the problem, because in order to find molarity, we need moles per liter of solutions. We got to get to moles. We have to use the molar mass to find the moles. So mass of solute, we'll end up actually dividing by the molar mass. That'll give us moles of solute. And then if we know the volume in liters, we can calculate molarity because it's moles per liter. So here's a problem with molar mass. So what is the molarity of a solution made by adding 3.45 grams of lithium hydroxide if the final volume is 250.0 milliliters? Couple things we're going to have to do here. First, we don't know moles yet, but we can use the molar mass of lithium hydroxide and the grams to find moles of lithium hydroxide. Second, remember, molarity is moles per liter of solution. Well, here is our final volume of solution, but it is not in liters, okay? Whenever we have milliliters, we're going to end up dividing by 1,000 to get to liters. So here's our molar mass. It's 23.95 grams per mole. To find the moles, we have to divide our grams by molar mass. So we find out that we've got 0.144 moles. And then to find molarity, we got to divide by liter of solution. So we've got to convert our 250 mils by dividing by 1,000 to liters. And then finally we plug it in. So our molarity of lithium hydroxide is the number of moles divided by the volume in liters, and so our final answer is 0.576 moles per liter of lithium hydroxide. Pretty straightforward. Now, here's another way to solve this problem using a handy formula that I created for you, okay? Here's this handy formula. Whenever you have grams in molar mass and you're making solutions, you can rearrange the equation to be grams of solute equals molar mass of solute times molarity of solution times volume of solution in liters. Now let me show you with the example we just had. So we're trying to find molarity, that's M, made by adding 3.45 grams of lithium hydroxide, that's grams of solute. Final volume in milliliters, well, we got the volume, we can convert that to liters, and we can use the formula to find molar mass. So we'll have grams, molar mass, volume in liters, solve for M, and we'll have our answer. So this is actually a simpler way of solving the problem that we just did. So you just plug everything in. There's your grams of lithium hydroxide. There's your molar mass of lithium hydroxide. M is what we're solving for. There's your volume in liters. And molarity is just going to be exactly the same as we calculated before. It's grams divided by the product of the molar mass times liters. And then you're going to end up with 0.576 moles per liter of lithium hydroxide, just like we obtained before.